Hello students, welcome again to our discussion. Today we are going to look at the rectification. We say that there are two major ways of rectification. We say that there's a half-wave rectification and also we have the full-wave rectification. Today we are going to begin with the half-wave rectification. In the half-wave rectification, we say that when a pulsating AC current is transferred to our transformer. This is the sign of the transformer. During the positive half cycle of this pulsating AC voltage, the positive half cycle. Remember that the diode, this side is positive and this side is negative. Means that during the positive half cycle, it finds the diode in the forward biasing, meaning that current will flow in this direction through our load RL. This is our load resistor. Now that the current will flow in that direction, meaning that the current will flow through the current flow will be from point A, through our diode, through our load resistor RL, back to the transformer at point B. That is during the positive half cycle. In the negative half cycle, we realize that here becomes negative and here becomes the positive. In the negative half cycle, the pulsating AC voltage through the transformer finds our diode in reverse biasing, meaning that this diode will not allow current flow, meaning that if we measure the potential difference across our load resistor with a voltmeter here, we realize that our load is 0 because the diode is in reverse biasing. That is reverse biasing. Now, let us look at the full wave rectification. The full wave rectification. In the full wave rectification, we do it in two major ways again. We'll say that in the full wave rectification, we have two methods. We have center tapped rectification, and also we have the full wave bridge rectification. Now, let us begin with the center tapped rectification. Again here, we will have our alternating AC voltage through a transformer. This is our transformer. This is the sign of a transformer. Now that in the center tapped rectification, we use two diodes. We have a diode here, and also we now look at the center tap of the secondary winding of the transformer. We take the secondary winding of the transformer connected to our load resistor. We say this is our load resistor, and here connected like that, and we complete the circuit like that. Now, let us say this is point A and this is point B. This is our diode 1. We have a diode here. We have a diode here. This is our diode 1, our diode 2, and this is our load resistor. Now, during the positive half cycle again of the pulsating AC voltage, we say that here becomes positive. We said previously that the positive terminal of the the diode is the side without a bar. Like this is the positive side, and this is the negative side. Also here is the positive side, the negative side. Now, during the positive half cycle of the alternating AC voltage, this is an alternating AC voltage, we'll find diode 1 in the forward biasing. Now, the current flow will continue in that direction, like that, through our load resistor and back to the transformer at point, let's say, P. Now, the current flow during the positive cycle, will be from point A through our diode 1, then through our load resistor, then back to the transformer through point P. You realize that this current will not continue in this direction because this is diode 2 is in reverse biasing. Now, let us see during the negative half cycle of the alternating AC voltage. You realize that the terminals changes. Now here becomes the negative, and here becomes the positive. We realize that the current flow during the negative half cycle, diode 1 is in reverse biasing, and diode 2 will be in forward biasing. Now, the current will not flow in this direction. The current flow, let us see now the current flow. The current flow will be from point B through our diode D2, then through our load resistor RL, then back to the transformer at terminal P. Now, we will say that this is the center tap full wave rectification. Now, let us see the disadvantages and the advantages of this center. We have said that before we look at the disadvantages and the advantages of the center tap rectification, let us see the sine wave of this rectification. We will see that with the time, and this is the voltage. We say that this rectifies the current in full wave. Before this rectification, you realize that before the rectification, you realize that current always have a sine wave. But now, after the rectification, you realize that the sine wave now changes. Now the rectified current will have such type of wave. The negative half cycle have been catered by diode number 2. Now we have this type of diagram. Now let us see advantages of this center tap and the disadvantages of. Let us see the disadvantages of the center tap rectification. It is difficult to locate the center in the secondary winding. Difficult to locate the center. Again, also in the center tap rectification, we realize that the diodes used must be of high peak inverse. Diode 2 must rectification. The diodes used must be of high peak inverse. Diodes used must have high peak inverse voltage. In our next lecture, we are going to look at the full wave rectification using the bridge. We are going to look at the full wave bridge rectification. Thank you so much. We meet in our next lecture.